Welcome to my video. My video tutorial is on the sine rule, the cosine rule, and finding the area of a triangle. And in this video we're going to do the proofs for the sine rule, cosine rule and triangle area, and then in a separate video we're going to have a look at how we use that in a few examples so we can get the hang of it. Alright, so I've set up a triangle that I'm going to need for all three proofs, and it's a simple non-right angle triangle where we've got angles A, B and C, and then we have sides labelled A, B and C where the side opposite the angle matches. So little a is opposite big A, little b is opposite big B, etc. Then what I've done is I've drawn a right angle perpendicular line from line C to angle C, and that's all that we need for this first one. So we're going to start out with the sine rule, and we're going to see how we get there. What we're going to use is we're going to make use of SOHCAHTOA, which hopefully you'll remember from GCSE, and we're going to make use of the first three letters, which is that the sine of some angle theta in a right angle triangle is equal to the opposite side divided by the hypotenuse. Okay, so how are we going to make use of this? Well, what we're going to do is we're going to look at what sine of big A is equal to. And we can see from the triangle that we've got this right angle triangle here, and if we want sine A, we want the opposite angle, which is H, the opposite side, sorry, which is H. We want that to be divided by the hypotenuse, which is little b. We're going to label that one. Now we're going to do exactly the same for sine of big B. And if we look at this right angle triangle, we see that the opposite is again little h, and that the hypotenuse is now little a. I'm going to label that 2. Right, by rearranging 1 and 2, we get that from 1, we get that h is equal to little b sine big A, and from 2 we get that h is equal to little a sine big B. Now all we have to do is equate these two expressions, and we get that little b sine big A is equal to little a sine big B. And then by dividing b from both sides and a on both sides, we get that sine big A over little a is equal to sine big B over little b. And you can actually see quite quickly by doing the same thing with sine C, that sine C over little c is also equal to those. And that there is in fact the sine rule. That is the sine rule. And it has another form, which is very, very simply the same same equation but inverted. So we have that little a over sine A is equal to little b over sine B is equal to little c over sine C. And the form that you'll use will basically just depend on the type of question you've got. So if you've got a question that's going to be asking you about finding a missing angle, then you want to use this top one, and to find a missing side you want to use this bottom one. It's as simple as that. So that is the sine rule derived. That's what we wanted to derive, and that's really great. So we can put a nice little QED down there to say that we have shown what we wanted to show, and we will move on to the cosine rule. Now the cosine rule states that in the same triangle we had before, a squared is equal to b squared plus c squared minus 2bc cos of big A. That's what we want to derive. And to do that, we're going to need our triangle again, which we have here as a reminder. And we're actually going to need to label this one a little bit more. So what we're going to do is we're going to get rid of this C for the time being. So this whole bottom side here is still of length c, but we're going to split it up into an x here. I'm going to call this vertex x, and this is now c minus x. Okay, and that's all we should need. Now, what we use for this is Pythagoras theorem on our two separate right angle triangles. So if we start with this triangle here, this left-hand smaller triangle, we can see that using Pythagoras, h squared plus x squared is equal to b squared. And we'll label that 1. And then from our slightly larger triangle, we can see that h squared plus c minus x all squared is equal to a squared. We'll label that 2. Now if we perform 1 minus 2, what we get is, well, the h squareds will cancel, and we get x squared minus c minus x all squared on one side, and we get b squared minus a squared on the other side. Now what we're going to do is we're going to expand this bracket here. So we get that x squared minus c squared plus 2cx minus x squared is equal to b squared minus a squared. So the x squareds will cancel, and we will end up with 2cx minus c squared is equal to b squared minus a squared. Now what we're going to do is we're going to rearrange for a, and we'll see that a squared is equal to b squared plus c squared minus 2cx. But we should note that if we go back a second to our triangle, we can see that actually, well, what can we see? We can see that x is equal to b cos of a, using SOHCAHTOA again. Okay, so with that in mind, we can substitute that in for x over here, and we end up with a squared equaling b squared plus c squared minus 2bc cos a. And that is the cosine rule. Okay, now this is also an iterative formula, which means that, well, a squared plus b squared, a squared equals b squared plus c squared minus 2bc cos a, but also b squared should equal a squared plus c squared minus 2ac cos b, and c squared equals a squared plus b squared minus 2ab cos c. And you can see that in exactly the same way that we have just shown the first one. So there's no tricks. I could do them all for you if you'd like, but hopefully you can see that they all come out of the same place. Brilliant. That is cosine rule done, and the sine rule done, and we've got one left to do now, which is looking at the area of a triangle. So we're now going to look at calculating the area of a triangle. And for this, we're going to need our triangle again. Let's bring that back. There's our triangle. Right, we're going to start from the position of the area of a triangle, area equaling a half the base times the height. Okay, and what we're going to see is actually, well, the base we can substitute in for c. So we can say it's a half CH. sine B is equal to h over a. So h is equal to a sine B. Substituting that in, that tells us that actually the area is equal to a half AC sine B. And it's also equal to a half AB sine C and a half BC sine A, which we may expect again that it cycles through all of the different permutations, and that is how you calculate the area of a triangle. Okay, that's great. That's all that we're going to cover in this video. Hopefully that's helped you understand a little bit about where they come from. In the next video, I'll show you how to use them.